Alright guys, now this video is going to cover a seemingly common fault I'm seeing with these Taramps amplifiers. This video will help you if you have come across a Taramps amplifier that seems to turn on perfectly fine with a single blue light and no protection, but you get no audio output. I'm going to talk you through how to diagnose where the issue is and possibly how to fix it. The first thing you want to do is crack the back off and check that you have your rail-to-rail switching square wave on the pins of the output MOSFETs. That's incredibly important. If you do have a big square wave rail-to-rail switching on these FETs, then this video won't help you. You have a problem elsewhere, possibly with the preamp circuit or with your RCA signal. If you don't have a big square wave on these MOSFETs over here, but the amplifier fires up perfectly fine, then this video might help you. The first thing that you need to do, I cannot stress this enough, before you start poking around and changing parts, remove the gate resistors. This isolates the output MOSFETs, and if you accidentally slip your probe, or if you change a part for something that's bad, or if it goes bad while you're working on it, you're not going to damage these very expensive output FETs. So the gate resistors on this one, this is a HD 8000, they'll be all different places depending on what model of amplifier it is, but these are these resistors here. These are 34 ohm gate resistors on this amplifier. The way to see which are the gate resistors is either to check continuity from the gate of the MOSFET itself. However, that doesn't always work, because on this amplifier we have this little chip which goes in between the gate and the gate resistor. So the best way to find which one the gate resistor is to check these chips, which are the SI chips, and go on the output pins and see which resistors are connected to the output pins. So in this case, we had this resistor here and this resistor, when the camera stops focusing, this resistor here connected to the high and low output pins of this SI chip, and therefore those were the gate resistors. So I went ahead and removed those, and that just isolates the output MOSFETs and prevents any further damage to the amplifier. So once you've removed those, you can start poking around the amplifier to see what the issue is. Now, I'll talk you through what happened on this amplifier, because this is coming to be relatively common on these that I keep seeing. So for the amplifier to work, for there to be a big square wave switching on the output MOSFETs, all these chips need to be operating, and these chips need VCC. They need their power supply voltage in order to operate. And one of the quickest ways to check whether a lot of the VCC circuit is working is to go over to the preamp section and take a look at the TL072C chips. And these are op amps to do with the preamp section, but in order to operate, they need VCC on pins 4 and 8. Off the top of my head, I can't remember which way around this is, but one of these needs to have negative voltage on it, and one of these needs to have an equal but opposing positive voltage on it. So, for example, on pin 4, you should have negative 15 volts, and on pin 8, you should have positive 15 volts. If you have anything other than equal but opposing voltages on pin 4 and 8 of all these TL072C op amps, then you have a problem with the circuit which is generating VCC for these chips and all the other chips, and that's why it's not working. So in my case, I traced the issue back to the VCC generation circuit, the low voltage VCC circuit, which is over here. Now, as you see here, we have an NPN transistor, which is labeled up as 56, and a PNP, which is labeled up as 53. And these transistors are responsible for generating VCC for these op amps in the Class D generation circuit, etc. And they work in conjunction with some Zener diodes in order to get the correct voltage. So you have transistor, Zener diode, and then you have a resistor across the Zener as well, which is about 330 ohms. Now, what I found in this amplifier was that I didn't have the correct voltages on the NPN transistor, which is generating the positive VCC for these chips. So we should have around 18 or 20 volts on the middle back pin here, which is what it's going to be regulating from. And then we should have on pins 1 and 3 the regulated voltage. I think we should have positive 15 volts there or thereabouts. On pin 1 I had positive 15 volts because that was the reference voltage coming from the Zener diode circuit, but on the output pin of here on pin 3 I didn't have anything. I had 0 volts, and I checked that over with the other one over here, which is generating the negative, and indeed I did have minus 18 or 20 volts, and on pin 1 I had minus 15, and on the output I had minus 15, so that was working correctly. However, the positive generation circuit wasn't working correctly, so I pulled this transistor and replaced it, and that didn't really make any difference. What happened is this was still showing as 0, so I changed the Zener diode. And because I took this out, and this was actually measuring 78 ohms across the Xenodiode, so that was faulty. So I took that out and replaced it, and then the output section started doing some interesting stuff. It started to try to come to life, but I still didn't have the correct VCC on the op amps, and it was acting a bit strange. I checked the voltage on the output of pin 3 again, and it was no longer 0 volts, but it was about 3 millivolts. It was very, very low still, and I thought, well, this is very strange. Why have I still got no output on here? The rest of the circuit seems to be operating fine. So I removed this transistor once again just to make sure that it hadn't been damaged by some other part of the circuit, possibly the Xenodiode that was bad. So I removed it, and I actually found that yes, this transistor that I had replaced that was working fine initially was now dead. These are this is the original one from the amplifier, and this is the one that blew again after I've already replaced it. So I was like, right, why has that transistor died again? The only reason that it would die is if something has drawn excessive current over pin number 3 to ground, because that will kill the transistor. So I was like, okay, I checked the resistance between pin 3 and main amplifier ground, and lo and behold, there was 20 ohms sitting there. So that's why that transistor died. So in order to find where this 20 ohms short to ground was on the board, rather than spending hours going through and testing every component on the board possibly which uses VCC which could be shorted, what I did was I took my positive power supply wire and I soldered it to the output pin of this trace here and left the ground in the board, and I turned my current and voltage regulated power supply to a very, very low voltage and very, very low current, like 1 volt, and allowing maybe 0.5 of an amp to pass. I then switched the power supply on, which of course passed current across whichever component was shorting pin 3 to ground, and I used my thermal imaging camera to find which component was heating up because it was passing the current and therefore it was faulty. And lo and behold, I found that the faulty component that was passing current and causing my short and therefore causing the transistor to fail was this CP27 tiny surface mount capacitor. I never would have found that, or it would have taken me a long time to find it if I hadn't known this little trick with the power supply. So that was getting to about 70 degrees Celsius. So I took this off and I read the voltage across it, and lo and behold, yes, there was 20 ohms across the little ceramic capacitor. So that got taken out. I found some replacements in a spare donor Taramps board over here, which is just too dead to repair, so I'm using it as spares. And I replaced the capacitor. I also replaced this capacitor because it had a chance to be damaged as well. I then replaced this once more for a third time and powered the amplifier up. And I had all the correct voltages on the op amps in the output section, so that was now working perfectly fine. And before we fit the gate resistors back in, you need to check that the Class D section is working fine and is fully operational. I'm just very quickly show you how to do that now. So I'm going to turn the amplifier on and just wait for the rail voltage to build sufficiently. I'm only allowing 4 amps to come into the amplifier just at the moment for power up because it's safe like this. Okay, here we go. So now we're in full operation. So to check with no gate resistors in, so with the gate resistors pulled out, if you want to make sure that your Taramps is going to work fine and is not going to blow the FETs when you put the gate resistors back in, you need to check that you have the following things. On pin number 1 of the driver chip, which is the one with the dot, you should have a nice little square wave here which rides up to about 2.8 volts RMS and is at about 40 kilohertz. That should be present on both sides because this is a full bridge amplifier, so both sides of this should be identical because they are in full bridge. It's 2 amplifiers in the same case. You should then check that on the gate resistor pads you have the following, and this could be in any order depending on which way around it is. You should have a selection of nothing, and then on one of the pads you should have a nice big square wave which references the input square wave at 40 kilohertz going up to about 9.3 volts. That will obviously differ with your input voltage. I've only got 9.9 volts going in just to keep things safe, but you should have a nice big square wave on the output on the gates, and then that's on the low side, and on the high side you shouldn't really have anything. If we probe the high side gates, we should just have DC at 10 volts, and on the other side also DC at about 9.7 volts. But provided that you've got a nice big square wave like this at 40 kilohertz on the outputs of the SI chips, and let's go over to the other side and check that we've got that over here as well. Yep, there it is on that side as well. Then you should be pretty safe to go ahead and fit the gate resistors back in, and the amplifier should be fully functional. And just to confirm to you, I'll just check these. The VCC voltages are correct. So on the back, on the middle pin, on pin number 2, as you can see there, we've got about, turn that up so I can see it. Yep, so we've got 18 volts for the input. Reference voltage on pin 1, we've got 15.3, and then output voltage on pin 3, we've got 14.7. So a little bit of voltage drop because things are using the voltage, and that's what that should be. And then if we go ahead and probe pin number 4 of this TL072C, you can see pin number 4 is the negative VCC, and pin number 8 over here is the positive VCC at 14.5. So there we go. Hopefully that has helped some of you guys out. If you can't get a Taramps that has full operation, lights, etc., but no sound output, and you don't get any Class D switching, check that all of your chips have the required VCC in order to operate. If they don't, trace back the circuit where VCC is generated, start replacing components, checking things with your multimeter, and seeing what the issue is, and go from there. The only other time that I've had a Taramps come in that had an issue where we didn't have any Class D switching, but the VCC circuit was fine, was to do with small ceramic capacitors in the section which helps generate the feedback loop. So you got a couple of TL072Cs in the middle here, and the chips here and the FETs, they create a self-oscillating environment. And it seems that the ceramic capacitors that Taramps are using are a little bit on the sketchy side, which goes true by my situation here with this CP27 going bad. So if you have an issue where you don't get any Class D switching, again, always remove the gate resistors. If you have all the VCC, take a signal generator. This is my signal generator, but you can use a mobile phone with a function generator app, plug in the RCAs, and play 40 Hertz, for example. And you should then be able to see a 40 Hertz square wave on the input pins to the driver chips, and you can follow that around the board and see where it disappears. And you can also just remove that, and you should, like I say, have the 40 kilohertz frequency, which is what it defaults to without a feedback loop. And you should be able to then follow that and find where it's losing the square wave as to why it's not generating a feedback loop. Cool. If you have any questions, guys, feel free to drop a comment, and yeah, like and subscribe if this has helped you out. I'll see you next time.